Good afternoon. Hi. My name is Simon. I am Vice President for Data Quality and Integrity at HealthVerity, and I'm joined today by my new colleague, Puya, from Prophecy. And we're going to talk to you about HealthVerity is moving to leverage both Databricks and Prophecy in our journey to protect the private nature of our data. I realize I'm probably one of the few things that's standing between you and lunch, so we'll try and keep this interesting, keep it interactive. So we'll have questions at the end. So today we're just going to go through who we are as HealthVerity, what our journey has been, what our challenges are. We'll have a demo from Puya on Prophecy and how they're helping to solve our challenges. We'll talk about some of the results we expect to see, and then we'll take questions at the end. So healthcare data is big, really big. Today, healthcare is generating one of the largest volumes of data. Every second, an exponential amount of data is being created, whether it is directly related to the healthcare of patients or whether it is the exhaust, the business transactions that go on around the industry of healthcare. In a world evolving into new personalized drugs, new drug therapies coming out every day, and the AI needed to be applied to solve some of the problems, the importance of accessing massive amounts of data, right, cannot be overstated. Right? The value of that cannot be overstated. One of our biggest challenges in healthcare is that the enormous amount of data is siloed. It comes from lots of different places, not all of which are coordinated. We may get medical records from our hospital system, but if the patient goes to see a provider who's out of network, that information is not connected. The pharmacy transactions are not always connected to the prescriber who made them. Lab tests tend to be in an ecosystem all of their own. So the challenge has been, how do we bring all that data together? It's often the responsibility of the patient to keep their doctors informed about where they've been and what they've seen. But now we need to analyze entire cohorts of data and provide a longitudinal journey of healthcare patient information throughout the entire life cycle of their treatment, from when they started, before they started, to when they're cured, or what their final outcome happens to be. So how does HealthVerity help in this? Well, we're connecting the dots. We broker healthcare data between suppliers and the customers who want them for their analysis. We need to do that in a way that provides them compliant-ready, analytics-ready data sets. We call that IPGE. I is for identity resolution. So even though the data is protected and de-identified, we provide a way of finding that patient, locating that patient across the myriad of different data sets so we can provide that longitudinal journey. P is for privacy. We do that while ensuring that our data has strict controls and adherence to the privacy rules, especially under HIPAA. G is for governance. We ensure that providers understand where their data is going, that it's not just going out to some other aggregator who then aggregates it and sells it on. And when necessary, we also work with patients to gain their consent if the data needs to be re-identified. Lastly, E is for exchange. We act as a third party between suppliers and clients so that these parties do not have to establish an entire network of connections and protocols in order to exchange that data. We provide that service. Sorry, went too far. The HealthVerity data lake represents close to 400 million identified patient lives and has close to 7 to 8 petabytes of data, billions and billions of medical transactions. We're able to connect multiple sources inside that de-identified data set by having a proprietary solution that helps us maintain an identity separate from the record, able to apply that across the entire data set. Our clients are able to do comprehensive patient-level research using this interoperable data set, and our ecosystem includes healthcare data from many large suppliers, hospitals, insurance payers, pharmacies, lab test organizations. We have a rich ecosystem also that contains niche suppliers, maybe rare diseases, oncology, and various things like that. We're able to connect those medical claims to those pharmacy claims, to those medical records, and onwards. We support many of the top pharma companies, both in their pharmaceutical development, their clinical trials, as well as in their marketing campaigns and outreach to patients. Leveraging Databricks and the Unity catalog, our data empowers our clients to drive meaningful improvements in patient outcomes. We synchronize the unparalleled identity management with built-in privacy and compliance. And we are facilitating real-world evidence and personalized care for patients with all sorts of chronic conditions. We're able to link mothers and babies and provide maternal outcomes, all through our proprietary technology. We lost the slide. Okay. So, HealthVerity data is de-identified. How do we do that? So typically, you want to start by finding a cohort of patients. You want to find them by index. You want to find by the disease that they are troubled with, the treatment or the therapy, the drug, maybe some other element of their demographic. All HealthVerity data must be de-identified under HIPAA. Our privacy rules act to protect the individual identifiable data, and under HIPAA, you can do that in one of two ways. You can either strip out all the identifiers that make up the HIPAA standard, as well as dates and anything that's truly usable by analytics, and that's called safe harbor. But that usually makes the data set unusable. So we go through another process where we do statistical analysis. We essentially establish a property called k-anonymity, which is the ability to re-identify any given data set. And as long as we maintain the ability not to de-identify, then that data set is covered by HIPAA. So our data problem is essentially we need to be able to remove the obvious protected health information and PII, the personal identifiable information. We're looking for things that establish risk of re-identification, whether it is a geography, where there's maybe a low population, whether it is an event in their history that is easily identifiable from the public record, like a crime or an accident, their date of birth, their date of death, various things like that. We also have to protect against handwritten free text. So if you've ever looked at a medical record, you'll find there's any number of places that a doctor can find to shove a piece of free text. And that free text can be anything from please call Simon to here's his telephone number. So we need to find all those places and protect those as well. So our basic use case is relatively straightforward. Our data arrives, we want to decrypt it, decompress it, we want to analyze it, we want to find that PII. If there's a PII or there's some form of protected information there that we need to resolve, that data needs to be quarantined. We need to work with the supplier. We need to work with our business analysts to make sure that data can then be completely and safely ingested into our data lake. Sometimes we mask that data, and sometimes we have to recode that data. Another challenge we have is that where can this processing take place? Ideally, we'd like a safe room, safe area, where we can bring that data on board, apply our rules, and when we're satisfied that it's clean, we can move it forward. And I think you heard in the keynote speech this morning, HealthVerity is part of the Clean Room initiative with Databricks. And finally, we come to the implementation challenges. So finding software engineers, data architects who fully understand our stack, who fully understand our needs, can be challenging. They're some of the most sought-after people in the industry, and they're handsomely rewarded as such. We want to open that role up. We want to lower the bar on proficiency. We want to make this more approachable through reusability, standardization, right? We want to be able to have the ability to check that we're doing the right thing through metadata. We want to be able to automate as much as possible through that standardization. And finally, speed. Speed is of the essence. We want to turn something that takes many months or many weeks to implement into a few days. So our solution has been on a journey for many years, but most recently, we took the step to adopt Databricks as our enterprise data platform. And a couple of years ago, we started to look for the low-code, low-proficiency platforms that would help us with the development of those pipelines. We chose Prophecy. Prophecy has a tight integration with Databricks. It is a low-code solution, meaning that we need a lower bar for people to start using it and using it meaningfully. It also provides a visual design interface to build high-quality data pipelines without advanced engineering experience. And the best part is that it generates 100% open Spark code. That means that we can look at the code, we can understand what it's doing. It's not a black box. We can check it into our GitHub. We can cut and paste it into our notebooks. We can examine how it works. So I'd like to turn this over to Puya, who will now give us a demonstration.
Thank you very much. Thank you. I'd like to stop right here and invite everybody on the back to come on up, find spaces that are left. So come off the wall, guys. Come on in. Take a seat, please. Make yourself comfortable. Everybody here, if you guys can squeeze in. Come on. Come to the middle, guys. Make some room from the outside. Come on in. Let's all get comfortable. There's rows and rows behind you, so come on in if you can. If you're in the middle, move to the side if you can, inside if you can. Yeah, and there's a lot of space up here. I got at least 5 people are here who can sit. So thank you, Enfisa. Oh, Simon, I'm sorry. Enfisa couldn't make it. Unfortunately, the tropical depression canceled her flight. So if you were paying attention to the title of this talk, we had to remove the title clean room. And that's because the nascent state of clean rooms, I wasn't able to get my hands on a clean room and play around with it. But based on what Simon was saying, you can see how important it is when dealing with this kind of data, that it's not yours, it's a vendor's data, to be able to have this kind of scenario set up. So in order to have a clean room set up, I thought I'd show you guys what we were told by the Databricks people, so you at least understand how to do it yourself. In order to have it, you need to have delta sharing. That needs to be enabled. And once it's set up, you can find it under the, no, I think I missed that one. Yeah, it's under the Delta Sharing tab. And so it has to also be enabled with Delta Sharing. The clean rooms has to be enabled. You'll be able to click on Create a Clean Room right there. Setting up collaborators requires having identifiers for each of the collaborators, their keys, and then picking the zone with which you're going to have the data available. Since this is private preview, only AWS is available with the US East region, but of course, going forward, many more regions will be available. So when you add a notebook to the clean room, you'll also need to specify permissions. Permissions can be independent on each notebook. And I might want one notebook that HealthVerity and the HealthVerity engineers are able to run, and other notebooks only the vendor, the data supplier, should be able to run. And you can have different permissions and different workflows as well. In this example, HealthVerity created the notebook, and the data supplier A has been granted permission to run that notebook. This is an example of a single notebook execution. Note that the process requires approvals from both collaborators before the notebook can be run by the permitted party. Each notebook can have a different approvals process. It can be stitched together in a unified workflow. And so Prophecy is working closely with the Databricks Cleanroom team so that the Prophecy UI will be able to integrate these executions that you see directly in the Prophecy UI, which you'll be seeing shortly. And so since you guys weren't able to see clean rooms now, there is a talk coming up right after this at 1:30, what's new with the data sharing and collaboration on the Lakehouse, from Delta sharing to clean rooms in room 202. So if you want to learn more, this is where you're going to learn more about clean rooms. All right. Before I jump into the pipeline, and now that you understand clean rooms, you know that Prophecy will generate the code that will run in this environment. And I'd like to explain to you a little bit about how Prophecy works. A Prophecy deployment is on Kubernetes and connects to any Databricks workspace through access tokens or to any Spark cluster through Livy. The Prophecy scheduler can take advantage of Databricks jobs or an existing installation of Apache Airflow. Therefore, foundationally, Prophecy runs on your compute and your storage. So let's jump over to the demo. Which I recorded earlier today. Excuse me for a second while I pull up my notes, which I forgot promptly in my hotel room earlier. All right, so this is the Prophecy landing page. This is the primary starting point for most projects that you start in Prophecy. And before I show you the demo, let me explain some of the things about the Prophecy entities. Let me click play. So for those who've never heard of Prophecy, it's a very simple drag and drop UI that allows you to generate high quality code pretty much in the back end on everything that you drag and drop into the UI. And it's done interactively. But what you need in order to execute that code interactively is a fabric. The fabric is going to come in the form of a Spark execution engine, or a favorite, of course, being Databricks, or a SQL provider like Databricks SQL warehouses. That's the fabric right there. And a project is where you link one-to-one to a project in a Git repo. So I start by typing the name of the project. And you can see this is where you can change the execution that your code is being generated in. I chose PySpark. Teams, you can collaborate with your collaborators on here. And you can see in the Git dropdown all of the different Git providers that are available. I'm going to use the built-in Git repository that's built into the tool. And this is where I select all of the projects that that team made available to me. And so this is really quick, but this is where the magic happens. This is where all the work has been done for me in preparation for this demo in order for this demo that you're about to see to be made very easy for me. So I'm going to start creating a pipeline. This is the new vendor data that's being supplied to me. And you can do batch or streaming. I chose batch. And I'm creating the new pipeline. And it's good to pause right here and show you all of the things that are on the canvas. So of course we have the source targets. Those are just the Spark read and Spark writes that you have. And then you have all the transformations. This is around 80% of all of the business logic that you would do in any Spark ETL pipeline. This is all encapsulated in the UI. Joining and splitting. And if you can't find it here, you could do it yourself. If you have custom libraries, if you have something else that you bring into the table, this is where you add it. And if you have a complex set of steps that you're doing, you can encapsulate it as a subgraph. And of course, as you saw there, from the template, the subgraph was being shared with me. And I started creating a source, a data source that my engineering team has already loaded into the data catalog for me. And those are other ones that have already been in the previous project that are also exposed to me, but I'm starting from scratch. So I'm going to click on New Data Set. This is my vendor one encrypted data coming in. And I locate it where it's going to be coming from. It's coming from Unity Catalog in this environment. Click on Infer Schema. This was a little bug I found earlier. Got to make sure it's reconnected to Unity Catalog. And then you could preview if you wanted to. We're going to go back here and continue with all the other subgraphs that are necessary. You can make this as modular as you want, as low code or no code if you want it, but I wanted to make it modular so you could see all the pieces that we were talking about. There's the decryption, decompression, pre-processing phase connected to the next phase, which is the checking the k-anonymity. If there is joining of data, which we are doing, such as the diagnosis and identifying rare diseases, we want to quarantine that information. So after the quarantining step, we can move on to masking the PII. So there's a lot of code underneath the covers of these subgraphs. And so the quarantining data is going to be put into a new data catalog, and the masked PII data, of course, is going to go into another data catalog as well. So this could be a business user doing this stuff with very limited knowledge of what's happening underneath the covers, with just what the engineers have told them is necessary for this vendor data. This vendor one could be, any data supplier, and it could have encryption with a specific encryption key. That's what they're supplying to me from the engineering team, and as a business user, that's all I need to know. This is the final output, the mass data. Making sure I select overwrite. So if the table already exists, I go ahead and overwrite it. There's many different modes available as well. And then the final step I have is to copy the tables from my local environment to my destination. And so these subgraphs are templates. You can pretty much run them by configuration, which you see right here. I'm adding the configuration variables that I need for each of those steps. And so these are the encryption tokens and the Databricks token that I need in order to connect to where the encryption tokens and Databricks secrets are stored. So I'm using Databricks secrets because this is connected to Git, and you don't want any of your secrets stored in your Git repository. This is the way you do it. So I'm showing you from the inherited template. These are the previous settings that were there. And I'm going in there and setting the default secrets and creating a new, in a second you'll see a new configuration for this vendor as well. I'm selecting the mask character that I want to use in order to determine what I'm going to be masking it as. And this is where I create the new configuration. And I have to tell the system where is it going to be looking for the column, the comments column, that would possibly contain PII, PHI leakage as well. And that will be the final step I have to take. That's a copy information that I need. All right, let's see where I start showing the data. Okay, so let me pause right here. And all I did was toggle between the visual and the code component. And you can see that it's generating better code than some of us can write. It's pretty clean. How many of you guys consider yourselves pretty decent Spark engineers or Spark writers? Right? Not many hands are going up. This is good. See some of my friends up there. You're not, unfortunately. But this is pretty much setting the standard for your engineering team, right? So when you look at the two engineers, right, or even the same engineer at different parts of the day before lunch and after lunch, their code is going to be drastically different. This is setting the standard for what kind of code is being generated. So as an engineering manager, this is definitely a nice way forward. It's code, yeah. It's pure code. Oh yeah, definitely something better. Yes, so let's go ahead into the model. And you can see that's too small, isn't it? Let me zoom in. Is that better? Okay. So this is a pipeline that I actually did run earlier today, and you can see that there are interim data set sizes that are there that I can step into and look at it and see what those results look like. So let's take a look at what that masking potentially looks like. If I hover over one of these columns, you can see, probably can't see that, but it's all stars, the patient's dermatologist, so it's identifying a name, so I'm taking out a name. So the model underneath it, we'll show you real quickly what that is at the end of this, but it's something that my engineering team decided. It could be any model. It doesn't necessarily have to be something that you have to purchase. It's not a platform. It's what your engineering team decides. And in the code base, what we'll share later, has all of the steps to set that up on MLflow. That's what we're using. So it's pretty much, this is what we're going to pretty much open up to you guys as a template that you can go ahead and take and say, okay, I want to use a paid model or I want to use a free model. And if we look at what that code looks like or one of these subgraphs looks like, you can see that there are steps in between them, and all of the interims are there as well. And for example, the decryption, this is something that an engineer wrote for me. It's Python code. And it's being generated back into the Git repository that this project is connected to. And if we look at the UDFs, again, the top ones are the ones for this project. The bottom ones are the ones that I inherit from the dependent project. And in that UDF, there is a PII get model response single with schema. That's what's taking the content in the string column that has the doctor's or the diagnostician's comments, sending it to the model, getting all of the entities that are in there. I was specifically looking for HCWs, healthcare workers, or PII, patient information, and then flattening that schema that was coming back, and then making sure that the parts that were the beginning and end of the string were identified, and then I was replacing them with a masking character. So, I mean, I did the coding myself, but this is how you would do it. So going back to the other presentation. Any questions about this before I jump off of this? All right. So the GitHub repo, Simple Data Labs, Inc., that's the name of Prophecy IO's parent company, automating sensitive data detection. I'm going to commit the demo code in there. So there's the base code, which that's what it is, and then there's the POC code, which I created right here this morning. That'll be in there as well. And it'll show you all the information about the model that I have as well. Let's see if I should be able to bring that up. All right, here it is. So this is the talk right here. Setting up the secrets is in there as well, in order how to load a secret. So all of these things that will really help you actually work with a environment like this. It's from beginning to end. If you undertake this, it'll make you very much more aware of how to use MLflow, how to use Databricks secrets. Highly recommend you play around with this. And where is the configuration? Hosting the model given here. All right. So this is the steps for hosting the model in MLflow. If you've never done this and you want to play around with building your own models, this is a great place to begin. And so the last invitation I have over for you before I turn it over to Simon is to check out some of the new features that we have. You saw me create the end-to-end pipeline. Our founder, Raj Maines, and our CTO, Maciej Spizowski, are building a generative app using this. So this is going to be really cool because you're going to tell Prophecy what you want, and it'll create that pipeline for you. And so this is going to be a really cool demo later on today. And Simon, back over to you for understanding what the KPIs were.
and we were able to increase the productivity for each user. So our main metrics of being able to do things faster, not have to use extremely in-demand engineers to get that done, were all achieved. The use of reuse, as you saw from Puya's demonstration of being able to take information that's already in the GitHub and apply it automatically, to use the code that you understand, that your team understands as the basis of that transformation. And more importantly for us is to then be able to establish the whole CI/CD process to get that code deployed. I think that ends our main presentation. If there are any questions, now would be a good time.